first session of the oral presentation. We have 5 presentations, 10 minutes each, and then after that we'll have 10 minutes group discussion. Our first presentation, sorry about my voice. I have a bit of a cold, and if I start having eye drops, I'm not crying, it's just the cold. So our first speaker is Harriet from our faculty, and Harprit Singh is a member of staff, and he's going to take us through one of our research on heart disease prevention. Thank you, Harriet.
Right, morning everyone. First of all, I'd like to thank the organisers for allowing me to present my research at this meeting. So a bit about my background. So again, I've been involved in several years of research, independent research, looking at the particular growth factors in proteins or angiopoietins. So what I'm going to sort of present today is some recent research which I'm engaged within the Faculty of Health in terms of looking at these particular proteins, their significance in especially vascular disease, and what relevance it has within the current research that's been conducted in the Faculty of Health. Okay. So a quick introduction in terms of what are these molecules. So these angiopoietins are, as I said, these are growth factors. They are made up of glycoproteins, made up of proteins as well as of glucose molecules. And the main role, especially in blood vessel function, is that they maintain blood vessel stabilization and protect the vascular, especially in adulthood. I just like to reiterate, obviously, during blood vessel angiogenesis, when you have blood vessel development, they're quite active during the neonatal stage, but during adulthood, they have a sort of a protective role, maintaining a quiescent vessel, a stabilized vessel. Okay, so there's 4 isoforms, or 4 types of this particular molecule, angiopoietin 1 to angiopoietin 4. So the well-known, well-characterized of the 2 molecules are angiopoietin 1, which acts as an agonist. So as an agonist, basically it acts on the cell, and the cell does something, reacts to cause that effect. Whereas angiopoietin 2 acts as an antagonist, basically it blocks the effect of angiopoietin 1. Again, rather complicating yourself too. Again, this is just put a diagram, just illustrating the structure of this in a sort of schematic sort of format. It's where you've got this monomer, this angiopoietin monomer, it's got this particular thread region, which is this particular region that acts on the cell by binding to a specific receptor, and we'll look at that in a bit more detail. And basically, you need 4 monomers of these to sort of oligomerize for the receptor to be activated by this particular ligand. So these ligands are, especially the angiopoietin 1, are important in vascular protection, and they're constantly released in circulation. They act on our blood vessels to maintain vascular stabilization and protection. Okay, and whereas we have this particular molecule, angiopoietin 2, which opposes the action of angiopoietin 1. So my interest, I'm from a cell signaling background, from a sort of biochemist. I'm quite involved in cell signaling. So one of the main sort of research I'll be looking at is looking at what signaling pathways, how does this angiopoietin 1 exerts its protective effects on the endothelial cell. So here's just a cartoon. So this is representing the endothelial cells. So the endothelial cells surround our blood vessels. So the blood vessels, they act as a barrier, preventing anything going in or out, and maintain the vasculature. And the way the angiopoietins act, they act on this sort of complex of protein receptors which are expressed, or which are present on the surface of this endothelial cells. So as you see, this angiopoietin 1 molecule binds to the receptor, and you can see within the cell you have these secondary messenger molecules which are activated. So this is just an example of a few molecules that have been identified that show some sort of effect. And some of the functional effects it has, especially looking at the cellular level, especially looking at this particular molecule, the PR3 kinase AKT pathway, which is quite essential in this particular cascade, is involved in survival, maintaining integrity of the endothelial cell. And again, if you look at another one, the ERK pathway as well, that's quite essential in sort of survival, remodeling, and leukocyte adhesion as well. So through these particular molecular cascades, the angiopoietin exerts this protective effect on the endothelium and maintain the quiescence within that particular blood vessel. This sort of signaling cascade has only been sort of being researched for the past 30 odd years or so. So again, at the moment, I'm collaborating with the research group, which are quite highly intense within this particular field. And we have done some proteomics work where we've identified quite interesting other molecules which might be involved in this signaling cascade as well. So hence that's an ongoing project, hence we're looking at these particular pathways in a bit more detail. Okay, but the whole sole event is that this is a receptor that's activated by this angiopoietin-1 molecule by activating these signaling pathways. So I told you about that. What relevance does this have then? So I've told you about the angiopoietin-2, its other sort of isoform, acts as an antagonist. And if you look at the list of sort of diseases where this particular molecule is elevated, so you've got tumor angiogenesis, sepsis, respiratory distress syndrome, diabetic retinopathy, and especially cardiovascular metabolic disease. And quite recently, you've probably heard the government is trying to invest quite a lot of money in, especially looking at research in dementia. And I was just reading, and this particular angiopoietin-1 molecule is shown to be some links of it to be involved in Alzheimer's disease as well. So it has quite potential in various diseases within the sort of social sort of and economical sort of output at the present. So the angiopoietin-2 molecule is upregulated in all these sort of diseases that I've just stated. And so you can see that this upregulation, what we assume that's happening is that its elevated angiopoietin-2 levels are blocking the protective effect exerted by the angiopoietin-1 molecule. Okay, and hence you have remodeling, vascular regression, sprouting, leakage, and hence leading to these diseases stated above. Okay, and so one of the things I'm currently looking at is obviously trying to identify what's the ratio between angiopoietin-1 and angiopoietin in individuals which might have factors that predispose them to cardiovascular disease. So I'm looking at the moment going through ethics to get some approval where I can identify these particular molecules through the salivas to see what sort of ratio, what sort of correlation these particular molecules have with age, obesity, BMI, or hypertension. So I'm looking at certain factors and looking towards that, their effect. Again, just want to lead to another sort of research which I just recently done and has been sort of published in the Proceeding of British Pharmacology Society, and I've been presenting a cell signaling meeting as well elsewhere, is looking at the effect of these molecules in patients with cardiovascular disease. So this is a quite neat, innovative technique that I've tried to characterise, where you get an individual, again these are the individuals especially going through sort of angiograms where they're given a sort of coronary catheter placed into them to isolate some endothelial cells. And so what we're doing is isolating the endothelial cells from the vascular and then looking at their effect they have on the cell. So what I've done is control patients and patients with cardiovascular disease, stimulate them with or without this protective molecule, angiopoietin-1. And what you can see in the control individuals, you've got increased activity of these cells. But in those which have been affected, or in those patients which have cardiovascular disease, their signaling profile has been sort of diminished. So that shows some sort of indication that these molecules do not sort of behave properly in a sort of a disease state. So that just sort of reinforces the importance of these particular signaling pathway in these vascular diseases and other diseases associated with this particular molecule. So obviously, what I'm currently doing is, again, the implication it has to healthcare. So currently what I'm trying to characterise or try to sort of define or utilise a particular sort of technique where we can use cells from these patients to look at an ELISA technique where we're using microfluidity type of ELISAs where we took in to look at ways to diagnose these particular markers and predict a particular vasculature. And rather than looking at sort of drug state, we can look at in terms of preventing. We can sort of prolong the onset of vascular complication by predicting the individual vascular by identifying these particular markers in those individuals. And currently, like I said, the collaborator, they are working on ways, or therapeutic ways, where we can trap or quiescent that excess angiopoietin 2 molecule, which is released during disease state, and how we can improve the angiopoietin 1 signaling in that particular vasculature. Okay, and finally, I just want to sort of just thank you, my sort of collaborators, so Professor Nick Binder's group at University, and obviously the research, the funders that have been contributed to this research. Thank you for your time.